In this question, we have a 300 kilogram box that is being pushed with a force of 385 newtons, while also being pulled with a force of 350 newtons. And we want to know what is the box's coefficient of kinetic friction if the box is moving with a constant velocity. Now the first thing we want to do is draw a free body diagram. And so we'll draw a point to represent the box. And then what you have to recognize is the box has a tension force acting on it from being pulled and a pushing force acting on it from being pushed. There will also be some kinetic friction between the box and the surface. And of course, we have the force of gravity pushing down on the box and the normal force from the surface pushing back up on it. Now that we have our free body diagram, we can write our F net equation, and we will use F net x to represent the sum of all the forces acting along the x-axis. And that would be the tension force plus the pushing force minus the kinetic friction. We can replace F net x with 0 because the box is moving with a constant velocity, so there's no net force along the x-axis. We can also replace the tension force with 350 newtons and the pushing force with 385 newtons. And then we can replace the kinetic friction with mu kn. Next, we will simplify this equation and rearrange to isolate for mu k, the coefficient of kinetic friction. And what we find is mu k is equal to 735 newtons divided by the normal force. Now how do we find the normal force? Well, we need an F net y equation, which would be the sum of all the forces acting along the y-axis. So that would be the normal force minus the force of gravity. We can replace F net y with 0 because the box is not moving up or down along the y-axis. And we can also replace the force of gravity with mg. Then we can rearrange and isolate for the normal force, plug in our values for the box's mass and the acceleration due to gravity, and what we find is that the normal force is equal to 2,940 newtons. And now all we need to do is return to our equation for the coefficient of kinetic friction, plug in the value of the normal force, and solve. And what we find is the coefficient of kinetic friction is 0.25. And that's the answer to this question. If you want to try other forces questions, check out my other videos to keep practicing and testing your knowledge.